Hi everyone. So today I have taken a question from NCERT exercise 12.3. This is question number 8. Now what the question says, let's see. The distance between two inner parallel line segments of a racing track whose left and right ends are semicircular is 60 meter and they are 106 meter long. If the track is 10 meter wide, find the distance around the track along its inner edge and the area of the track. So this is the track, you see. This is, you see, I have shown by cross section, that is, this part, this much is your two rectangular part which are parallel to each other, and the distance between inner parallel sides of these two uh, segments parallel is 60 meter as shown, and the length is 106 meter of this side, parallel sides, and the ends are semicircular, as you see, semicircular rings. They are semicircular rings. Okay, so the width is uniform. Width of the track is uniform and it is of 10 meter wide. So these dimensions are given to us, and what you have to find, the first part, the distance around the track along its inner edge. That means this is the inner edge. This distance we have to find. So obviously the distance will be, so if I consider this rectangular part, so this part is nothing but length of the rectangular part, 106, and what is the width of this rectangle? This width is your 10 meter. So this width is nothing but your 10 meter. So 10 meter is your the breadth of the rectangular. This is breadth. Okay, so these are given to us, and now this is 60 meter. So this is 60 meter. So the midpoint will be somewhere here. Say if this is the center, say O, then the radius, this will be radius, and this radius will be half of 60, it will be 30 meter. 30 meter is the radius. This is this 30 meter radius of the inner semicircle. So if this is your Ri, so let me write Ri of the inner semicircle is 30 meter, and if this is the external one, that is, if I consider it to be, say, R external, so RO, say outside, so RO is your, what will be this? This is your 30 plus this 10, so 30 plus 10, 30 plus 10, this will be 40 meter. So these dimensions we have. So the inner length, length of the distance around the track. So this distance will be twice this length, okay, plus this semicircular circumference, twice, one this way, one another way. So in the first part we write answer of the first part. The required distance will be this L plus this L plus this, or let me write twice of L plus, now this is your semicircular circumference, that is pi r. So pi, and radius is your Ri. For inside internal it is pi r, and it is also one for this and one for this, so 2 times. Okay. So this is, so now just put the values and let us calculate. So twice L is your 106 plus 2, and Ri is your 30. So 30 is not a multiple of 7, so I can take value of 5 to be 3.14. 3.14, and Ri is your 30. So I can take 2 common here also. 2 common, 106 plus 30 into this, it will be 40, 42, 942. So 9420, this will be the thing. So this will be 2 into 106 plus 9, 200, 200 and 0.2. So the answer is 400.4 meter. So this is the answer of the first part. Okay. So in this way calculate the distance along the track along its inner edge. This one. Now for the second part, the area of the track. Now again you see area of the track as you see. So this is that's a rectangular part, two identical rectangular part. Let me mark it, say first region 1 and say this is region 2, and these semicirculars let me write say region 3 and say this is region 4. So the track has two identical rectangular part which are your 1 and 2, 1 and 2, and has two identical this semicircular part, semicircular region, semicircular ring, rings, and which are third part and fourth part. So this you have first identified the area of the track. So we have to add these areas. So therefore answer, therefore the required area, two identical rectangular parts. So I can write twice of LB because this rectangular L and B are the dimensions of the rectangles, length into breadth. Then for two rectangle, 2 into LB plus two semicircular rings. Now semicircular ring, you know, you have a semicircle like this, and there is inside one like this. So how we can find out this area semicircular ring? We simply subtract this inner semicircular area from the outer semicircular area. That we do. So it will be here like this. So this area is nothing but, see, it is inside Ri inside area, and this is outside area is Ro. Then this area will be pi Ro square half, because it is semicircular, minus pi Ri square. This is the area of this ring. So we'll be using this formula. So I am writing this half pi, and I take pi common, Ro square minus Ri square, Ro square minus Ri square. So I think this is, you have understood why I have written in this way. So these two getting cancelled, and simply put the values twice. L is your 106, 106, and the breadth is 10 meter into 10 plus pi. I don't know what value I will be taking, let me put pi only. Now it is a square minus b square, so I will use identity a plus b into a minus b. So Ro plus Ri into Ro minus Ri. Okay. So it is now 106, double of 106, 212. So into 10, this plus. Now let me write pi. Now let's see what is Ro plus Ri. You see, Ro plus Ri is 30 plus 40, it will be 70. So it will be 70. So I can take the value of pi to be 22 by 7 because of this 70. So into all, let me write one more step. Ro is your 40 outside radius, inside radius is 30. And Ro minus Ri, you see, this Ro minus Ri is nothing but the width of the track. This Ro minus Ri is width of the track. So I put the values. Now 40 plus 30 is 70. Now I let me write down 70 directly now. Okay. So it is 70 and the width is 10. So the calculation is very easy now. 10. So what is this? 2120 plus 22 zeros. Okay. So how much it is? 4320 meters square. So this is the area of this track. Okay, 0.4320 meter square. So these are the answer of first part, answer of the second part. So you see here the way I have done the calculation, or I have done solve the question, I have not done any rough work. My calculation is so easy. So in this way we can manage the calculations, okay? Next question is again from the NCERT, exercise 12.3 and question number 9. So this is the question. A, B and C, D are two diameters of a circle with center O perpendicular to each other, and OD is the diameter of the smaller circle. If OA is 7 cm, find the area of the shaded region. So this AB and CD, these are two diameters of the circle with center O, and they are perpendicular to each other. So this is 90 degree, and this is OD is the diameter of this circle, and it is given that this OA is equal to 7. Now this OA is nothing but your radius. OA is the radius, so it is equal to 7 centimeter, it is given. So if OA is 7, then OB is also 7, OC is also 7. So this OC is also 7, or let me write. OC is equal to OB is equal to OA, all are equal to the radius, and it is given to be 7. So this is given to us. In the diagram we find this. And so how to find the area of the shaded region? So let me mark the area of the shaded region. So let this part be region 1, say this is region 2, and say this is region 3. So what you have to find? We have to find solution. We have to find the area of region 1 plus 2. 1 plus 2 plus area of the third region. This is we have to find. This is we have to find. Now what are these things? So you see, if you observe, this area plus this area is nothing but the area of this semicircle with AB as the diameter minus area of this triangle. Okay. And since we know the radius of this semicircle, we can very easily find out the area of the semicircle. And since this is 90 degree, so if this is base, this OC will be altitude. So with the formula half base into altitude, we very easily can find out the area of this triangle. So we can do it. So let me write out. This is nothing but your area of semicircle let me write ABC minus area of triangle ABC. Area, okay, let me write area of triangle ABC. This is your this part, this one. Then plus, let me erase this one. Plus area, third part is nothing but area of the circle. This is the circle area. Area of circle with OD as the diameter. OD as diameter. So this is very important step to write, because I have shown my understanding. So how I am calculating the area of the shaded region. So now next step we will write the formula. So semicircle area formula is pi r square by 2. And this area of triangle half base into altitude, because it is a right triangle. Actually it is a right triangle because this is diameter and this is your 90 degree. But better let me write half base into altitude, since this is 90 degrees. So it is a simply take triangle. Though it is a right triangle, but it will not be using that property. So half base into altitude, this part, then plus area of the circle is pi r square. Okay. Now this r is your, what is this r for this OD is a diameter, so we should write instead of pi r square. Okay, no problem. When we're putting the values, we'll be a bit careful. So now pi Actually there may be confusion. Let me write say it is R1, so let me R2, then there will be no confusion. So this OA is equal to R1. This is the radius of this big circle is R1, and R2 is your radius of the smaller circle. So this is your OD by 2. OD is the diameter, and what is OD? OD is again equal to the radius. So it is 7 by 2 centimeter. So in this way we find out. Since because this OA is radius, that's why OC, OB, all are your equal to the 7 centimeter. Now put the value. So what is R1? R1 is 7. So I write 7 into 7. R1 square, so 7 into 7 by 2. And let me put the value of pi to be 22 by 7 because 7 is there. So 22 by 7, the value of pi is taken. Then minus half base into altitude. Base for the triangle ABC I have taken AB. So let me write AB. Base is your AB. And the altitude is your OC. Let me put the value, okay. Then again here pi is 22 by 7, and what is R2 is 7 by 2. So square, so I write it 2 times 7 by 2. Okay. So now let me do the calculations. So 11 into 7 is 77 minus half. AB, what is AB? AB is the diameter. So it is double of this R1, so it is 7 into 2, 14. And OC is 7. This is again I am cancelling out. So it is 77 by 2. Next what will I do? I cancel this one 7. So here in the 77, don't divide. Let me take common. You see I am doing the calculation management. 1 is here and plus half. Minus 7 square is 49. In the next step let me write 1 and half is 1.5. Minus 49. So let me do this multiplication by 15. You know the table of 15 very easy. So if you multiply by 15, 77 into 15 will be 115.5. 115.5. This and minus 49. This is very easy calculations. And then if we subtract, we'll be getting 66.5. Unit is centimeter square. So this is the answer. This is the area of the shaded layer. So in this way we are solving the things. Actually practically we are not doing any rough work by observing the things. So we calculate, we find, instead of finding them separately and doing this subtraction and all, we can take doing this way, taking common and all these things. Okay, so that's all for today. Bye.